One video to master types of ores, roasting and calcination. Hello students, let us start. Ores and steps involved in metallurgy. Metallurgy, the study of extraction of metals from minerals followed by purification. Mineral, a substance from which metal is extracted. Ore, it is mineral from which metal can be extracted profitably and conveniently. Remember, many minerals available. Any substance from which metal extracted is referred as mineral. But out of many minerals, minerals from which metal can be extracted profitably and conveniently is ore. Remember. The order of abundance of elements in Earth's crust: oxygen firstmost, silicon, then aluminium, iron. Abundance in Earth's crust. Gangue meaning impurities, flux meaning chemical substance that is added to an ore to remove gangue. So flux and gangue together we call it as slag. Flux and gangue together called as slag. In extraction of iron we use flux, that is calcium oxide. So iron contains silicon dioxide impurity. Flux combine with silicon dioxide to form calcium silicate, which is slag here, which is calcium silicate. Types of ores: native ores as well as combined ores. Native ores meaning metal is in free state or elemental form, like silver, gold, mercury, palladium, platinum. Commonly reactivity is less. Most of these elements exist in free state as well as in combined state also, but most in free state. Combined form, like they combine with oxides, carbonates, different. So here oxide ores, carbonate ores, sulfide ores, halides, nitrates, phosphates. So different ores given here for your reference. So you can refer it. You can refer it once for your reference. Okay, refer the entire list of ores. List of ores and common formulas are most important. Many questions previous class in JEE Advanced as well as mains. So among these, here these are very important. Siderite, that is zinc blende, even galena. These are most important. You have to remember those names. Malachite, even these are important. Calamine, very important ores. Such important list of ores given, once you refer it and remember. Even cryolite, important. You refer it. Steps involved in metallurgy here. First step, crushing and grinding. Here big lumps of minerals crushed into smaller particles. Then after pulverization process, it convert into powdered ore. Pulverization meaning the process of converting smaller particles into powdered form, powdered ore. Later, after converting to powdered form, concentration of ores or dressing of ores, the process of removal of impurities so that concentration of ore increases. Further physical methods what we are using here: hydraulic washing, gravity separation, levitation. Here it is based on difference in density of ores and gangues. So what we do here, here we place under stream of water, here we place the powdered ore along with impurities. If you place powdered ore along with impurities, as water running here, heavier ore particles trapped in these grooves of the setup, heavier particles of ore trapped here, lighter particles of gangue washed away along with water and collected here, lighter particles, purely based on density, weight. Froth flotation method, it is important. It is suitable mainly for sulfide ores. Mainly for sulfide ores like PBS, zinc sulfide, copper, iron sulfide, etc. Based on difference in wetting properties of the gangue and sulfide ores with oil and water. Wetting properties, that is affinity. Affinity with respect to get solvated or get dissolved with respect to oil and water. So attraction towards oil and water, you can say here. Wetting properties of gangue and sulfide ores with oil and water. Like sulfide ores shows attraction towards foam or oil. Gangue particles attracted towards water. Frothers helps in making froth like pine oil, camphor oil, eucalyptus oil, mainly used to generate foam or froth, like soap. Soap solution generate foam, similarly here frothers used. Froth activators stabilizes froth, helps in stabilization of froth to maintain froth. Amines, cresols, aniline added so that froth remain for longer time. Collectors are floating agents, which helps in collection of froth. So here you can take example like sodium ethyl xanthate, sodium or potassium ethyl xanthate. These are commonly used floating agents. Sodium or potassium ethyl xanthates. These makes ore insoluble in water. These substances makes ore insoluble in water and comes to top along with foam. Comes to top along with foam. Depressants or activating agents are activators. Depressants example NaCN, sodium cyanide, activating agents copper sulfate. When we use this, when more than one sulfide ore present in the solution, think that zinc sulfide PbS present. More than one sulfide ore present, we need to separate only one sulfide ore. Think that our target is only to get PbS. Then what we do, PbS shows floating property. Floating property meaning here we'll discuss now. So here these can activate or depress the flotation property, a floating property, and help in separation of different sulfide ores present in mixtures. For example, see both are sulfide ores, we need to get only one sulfide ore. Assume that zinc sulfide is in less amount or it is acting as gang. Now if you add NaCN here, if you are adding NaCN which is depressant, so here depressant combined with zinc sulfide, floating property of zinc sulfide depressed, hence only PbS goes up. NaCN combined with zinc sulfide which makes it heavier. At the same time we can say floating property of zinc sulfide depressed. Depressed meaning that deactivated, hence only PbS goes up, zinc sulfide goes to bottom in the container. So PbS goes out or goes up in the form of foam to the surface, whereas zinc sulfide remain at the bottom. So what happens in this process? See, here we are taking one container. Into the container we are adding ore plus water plus oil, fine oil like frothing agent, ore plus water plus oil. From outside we are sending air here into the container which is having holes, this setup. So air coming out from this container, and then after reaching to the container, because as we are continuously passing air here, so due to introduction of air, agitation occurs, mixing of solution occurs which generates foam. As we know, sulfide ore particles shows attraction towards foam. So all the sulfide ore particles shows affinity towards foam, as foam is lighter. So foam comes to top. Foam comes to top along with ore particles. Whereas heavier gangue particles or heavier zinc sulfide particles here settle down at the bottom. Okay. So overall foam contains ore particles and along with foam taken into separate container, then we'll recollect it again. But heavier gangue particles or if any impurities like zinc sulfide stay at the bottom. Okay, so role of NaCN which facilitates the floating property of one of the ores, other ore like zinc sulfide combine with zinc sulfide. So after combining with zinc sulfide, NaCN destroys the floating property of zinc sulfide and comes to bottom. Hence you can collect ore particles from the foam later, heavier particles of impurities or any other left over at the container, bottom of the container. Next, magnetic separation. Either metal or impurity should be magnetic for this. SnO2 ore non-magnetic in nature, but impurity is present in this ore. Iron tungsten oxide, manganese tungsten oxide are magnetic in nature. So here we are taking, here there is two wheels where conveyor belt also present. Conveyor belt, it is moving throughout, given two wheels. Here one it is leather belt. So it is magnetic roller. These are magnetic rollers. So what happens? One is non-magnetic, one is magnetic roller. Here magnetic roller, when powdered ore placed on this conveyor belt which is under movement. So these magnetic particles along with impurities pass near to this conveyor belt, near to this magnetic roller. As it is magnetic in nature, for example here, magnetic impurities attracted towards roller and form heap near to magnetic wheel, whereas non-magnetic ore particles thrown away. Non-magnetic ore particles thrown away collected here, which is SnO2, non-magnetic ore particles. So one should be magnetic so that whichever is magnetic collected near to the wheel, non-magnetic thrown away. That's all, simple separation. Chemical methods, leaching or chemical treatment. Silver ore along with impurities when allowed to react with reagent NaCN combine with silver. NaCN combine with silver and form a soluble complex. So once if it is combined, forming soluble complex, impurities left over in the container itself. So impurities left in container, whereas silver we transformed. We are transferring silver in the form of soluble complex into another container. Impurities left over. Bayer's process. Bauxite, Al2O3 reacting with NaOH forming one soluble compound NaAlO2. This NaAlO2 again reacting with water on heating gives one precipitate AlOH thrice. AlOH rise on further heating gives here Al2O3 plus 3H2O. Here also we removed impurities if any moisture. By this process moisture removed, impurities if any removed, but finally we are getting Al2O3 here. So what we are doing here, by using this method, that is second method. First method is crushing and grinding. First step crushing and grinding. Second step concentration of ores or dressing of ores. Under concentration physical methods A, B, C. Under concentration chemical methods leaching like examples given. And the next step conversion of ores into oxides. Here ore is converted into metal oxide form. So number one method, that is roasting, used for sulfide ores. Roasting. When ore is heated in the presence of oxygen, it can convert into metal oxide. Like sulfide ores on heating in presence of oxygen gives metal oxide, sulfur dioxide gas goes out. Advantage of roasting, excess sulfur is removed in the form of SO2 gas. Metal sulfide converted into metal oxide, desired target. Impurities are removed as their volatile oxide. If any impurity, they are converted into oxide form and goes out in the form of vapors. Another method under conversion of ores into oxides. Third step, first step is crushing and grinding. Second step, concentration of ores. Third step, conversion of ores into oxides. Total 5 steps. Third step, it is conversion of ores into oxides. Calcination used for carbonate and hydrated oxide ores. Ore when heated in the absence of air, it is converted into metal oxide known as calcination. Like metal carbonate gives metal oxide and CO2. Hydrated oxides gives metal oxide plus moisture removed. Advantage of calcination, moisture removed, organic matter destroyed, metal becomes porous and easy to work or easily workable. See the question now. JEE Advanced 2019 question. What they gave, observe it. Calamine, malachite, magnetite, cryolite respectively given. So direct formulas given. See here, calamine it is zinc carbonate, malachite it is CuCO3 CuOH twice, magnetite Fe3O4, cryolite Na3AlF6. So direct formula based task, JEE Advanced. Next, which one of the following ores is best concentrated by Froth flotation method? See, Froth flotation method, malachite already we discussed here itself, CuCO3 CuCO3 dot CuOH twice, magnetite Fe3O4, siderite FeCO3. See, all these ores I gave already in the list. Above list every ore you can find. Once if you refer those ores, more than sufficient. Galena it is PBS. And we know Froth flotation method, once you observe it. Froth flotation method, the important point what we wrote here, it is used only for sulfide ores. So Froth flotation method, Galena PBS, sulfide ore, so it is used for concentrated by Froth flotation method. So for that, what you have to remember? You have to remember the list of ores whatever I gave. Okay. I hope all the questions clear to everyone. For more updates, follow the channel. Thank you. Thank you everyone.